There are four typical areas where we run into problems as we're developing our test bench, and these are areas where UVM can help us out. For starters, when we create our objects in our test bench, sometimes things may not get created as we expected. For example, maybe our agent got instantiated as a passive agent and we didn't get the active components we were expecting. Or if we're swapping things out with the factory, we might not get what we're expecting either. So we need some way to go in and debug what is our structure, what does our hierarchy look like. Also, we may run into problems with connecting things up, whether it be your TLM connections or your virtual interfaces. We need some way to be able to see what's connected to what. And similar to that is we need to be able to use the configuration database to maybe pass that virtual interface, or maybe we need the configuration database to determine whether an agent is active or passive. So we need some way to look into the database to see what's actually being set. Did we set something before we needed it or after we needed it? Sometimes that makes a big difference. So by having some way to peek into that database will help us figure out what's going on. And then lastly, there's also synchronization, whether it's synchronization using the objections or maybe it's using the runtime phasing. So having the ability to see what is executing at what point and in what phase may help you figure out why your test bench isn't doing what you expect it to do. With that, let's start by looking at the debugging features for component creation and our connections. One of the most useful debugging aids in UVM, I think, is the print topology function. With print topology, it will print out what your test bench hierarchy and structure looks like. And I think that this should probably be put in any test bench, at least at the top, be printed out very early on in your log file so you have it there for debugging purposes. Also, it's quite useful when you go to access the configuration database because you can look at the print topology to see exactly what the path is to make sure that you get everything correctly. Now, there are two ways to use the print topology method. First of all, you can use it directly, as we show here in the middle of the slide. You see it's commented out, UVM top.print topology. But this is too early because we haven't actually started running our test case. We have to do the last line there, UVM run test, before we can print anything out. But instead, what you could do is you can just tell it to do it automatically. As you see in the second to last line here, we say enable print topology equals 1 so that as we run the test, it will then go ahead and print out our topology for us. Let's take a look at what the results are when we print out the topology. Here's an actual output of the print topology function using a UVM environment that we have loaded up on the EDA playground. And what you can see is that we've called print topology directly by calling it on UVM top in our start of simulation phase here. What I like about the topology is that it shows us the structure, it shows us both the components, but it also shows us the connections or the ports that we have in our environment so that we can see, did everything get instantiated correctly? If there are individual variables, that shows us the size and their value. For most of our objects, you can see that the value has some sort of @ number there, and that simply is a number representing a reference to an object, which we pretty much ignore most of the times. But if you are curious to see whether something points to the same object or not, you could use that value there to confirm that. But this allows you to see what the hierarchy is so that, especially as you go to see whether, like for example, did my agent instantiate all the components or not, or later as you go to use the configuration database, you can make sure that you've gotten your hierarchy constructed correctly so that may explain if you're having problems with your config database. It may be that you just didn't use the right hierarchical path name, and this will help you figure that out. If the topology isn't enough to debug your TLM connections, you can also use the method shown here, debug connected to, on your TLM ports, and you can print out what the fan-out network is to see where things are being connected to, as well as you can use this one here, debug provided to see what is fanning into your particular TLM port. Let's take a look on the next slide at an actual example of using these methods. Here we're using the debug connected to method on the analysis port of our bus monitor, and you can see it prints out two things. It prints out a hierarchical view of what the connections look like, as well as at the bottom a list of the three things that are connected to it. If we take a look at a diagram of our test bench, this indeed represents what we have. We have a analysis a connection here on our instruction monitor. We have one on our ISS reference model, and we have one on our scoreboard. And the hierarchical representation goes a step further and says that not only are we connected through the export on our scoreboard, but we also have an internal connection that connects to our UVM comparator that we're using, and it even dives deeper and says there is a connection to that inside of the UVM comparator. So this helps us to visualize what's going on, and we can very quickly come in and see, did we connect something up incorrectly, and figure out why perhaps our analysis connections or whatever TLM connection we have is not working. To view the fan-in, all we have to do is call debug provided to method, and as we show here on the ISS export of our scoreboard. And if you recall from the previous diagram, we only had one connection to that. So you can see that this is showing us that there's an analysis port on our ISS reference model that is being connected to the export on our scoreboard. In the previous two examples, we've hard-coded the calls to debug connected to and debug provided to inside our test bench, so that information will always be printed out to the log file. But what if we don't want to clutter our log file and we just want to have that debugging information when we're actually trying to debug something? So what we can do for that is use this global function built into UVM called UVM report enable. And with this function, we can put it in an if statement and query UVM to say, are we at a debug veracity? And if we are, then we can use that to qualify whether we print out information into our log file. Now with a slight modification to our previous code, you can see that we've added in the UVM report enable to query, are we at a debug veracity level? And if we are, then go ahead and call our methods. And this way you only get that information dumped into your log file when it's absolutely necessary. With the debug connected to and the debug provided to methods, we have to visually inspect what gets printed out to see if there's a problem. But there's also a get provided to and a get connected to method that will return an associative array of the different ports that are connected to our analysis port in this case. And that allows us then to iterate through that list and check to see if everything's correct. If we find anything that's not what we expect, then we can go ahead and print a message. So just another way that we could actually add checking into our environment so that when we go to create the environment, it can check the connections itself and tell you whether everything is correct. We saw that the print topology method was really useful at printing out the different components in our environment and showing us what the structure is of our test bench. But as we start to use the factory to swap in different components, perhaps we want to swap out different agents, maybe we want to even swap out different types of transaction objects. So we want to have an error injection transaction instead of the regular type of transaction. As we start to use the factory and override the different types, we may need something more than just print topology. So what UVM allows us to do is to actually print out what's in our factory. And the way we do that is we simply get a reference to the factory object. So we can call get on the factory to get that singleton factory object reference. Then we can do our different overrides, whether it's a type override or instance override. And then all we have to do to see what's in the factory is to call print on the factory itself. And here's an example of what the factory printout looks like. You can see from the dump that it lists out all the different types of objects that have been registered with the factory. And you can also see at the very top that there are no instance or type overrides that are registered with the factory. So now you can easily see, if we were to do overrides and such, you can see which type is going to be swapped for which other type.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of Doug's webinar, Debugging Features of UVM, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the KnowHow area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.